We'll cover these four normal functions today: rnorm, pnorm, qnorm, and dnorm. Each function will require a mean and standard deviation. If you don't specify them, the mean will be 0 and the standard deviation will be 1. You'll get a standard normal distribution by default. First up is rnorm. This will randomly sample n numbers from a normal distribution. If I enter rnorm 100, I get 100 numbers from a standard normal distribution. Let me store one of these as z so I can work with it. If I take the mean of this, it should be pretty close to 0. And the standard deviation should be pretty close to 1. And if I change this, let's say now I want a sample of 1000 from a mean of 100, standard deviation 10. I actually want to do that here. Now the mean should be more like 100, and the standard deviation should be more like 10. And this is useful for simulating things. I used this rnorm to simulate the animal weights for the farm example in week 1. Here's a histogram of it. If I run this a few times, you can see what the histogram for a sample from a normal population looks like. It's not always going to be perfectly symmetrical because of the randomness of the outcomes, but if you see something like this, you might think that you're dealing with a normal population and you'd analyze it with the mean and standard deviation. Next, we have pnorm. This will find the area under the curve that is behind x. So if I want the area behind 30 when I have a normal curve with mean 50 and standard deviation 10, I do this. And I get 0.0227. So a little more than 2% of the area is behind 30. Let me draw a picture of what's happening. This polygon syntax is kind of weird. I don't expect you to learn this, but I do want you to be able to draw a normal density curve like this, and I'll talk more about that in a minute. But anyway, this is what I'm doing with pnorm. I'm finding the area that's behind the number 30. If I want the area that's in front of the number 30, if I want this, there are a couple of ways to get it. Since the area under the curve is always 1, we can take 1 minus the area we just got, 1 minus 0.0227, and that's 0.09772. We can also set lower tail equals false. By default, it's set to true, so it finds the lower tail area, but if I do this, I'll get the upper tail area. Say I want this area here, the area between 30 and 70. What I can do is find the area behind 70, which is this, and then subtract the area that's behind 30, which is this. And that's 0.9545. Qnorm will find a quantile given an area. A quantile is like a percentile, but it's a proportion rather than a percent. If I want to know the 0.6 quantile, which is the number such that 60% of the area is behind it, I use Qnorm. Qnorm 0.65010 is 52.53. So this number here would be 52.53. What if I asked you to find the other side of the quantile? What is the number such that 20% of the area is ahead of it? Q norm will only refer to the area behind the number. But if 20% of the area is ahead of it, then 80% must be behind it. So we need Q norm 0.8, 50, 10, 58.42. Finally, D norm will give you the height of the normal curve at the number you specify. For example, if I want this height here, the height of the curve when x equals 60, I would enter D norm 60, 50, 10. And the height is 0.024, which as you can see, it's kind of like that. D norm is used for drawing the density curve. If I ask you to shade the curve, you can do it by hand or using a paint program or something. You won't have to shade it in R. But drawing the curve itself is just like what we've been doing, so you should be able to handle that. We use the plot command and we give it an x and y as before. First, we'll draw a standard normal curve. X will be the numbers from negative 3.5 to 3.5. Remember the 68, 95, 99.7 rule? Hardly any of the area is beyond 3 standard deviations. So if I go from negative 3.5 to 3.5 when the standard deviation is 1, it will capture just about everything on the curve. And I'll make it a sequence by 0.01 just so it has a good resolution. My y will be d norm x. I'm drawing a standard normal, so I won't have to specify a mean or standard deviation now. I plot all this, and I set type equals L to get a line. To graph a general normal distribution with mean equal to mu and standard deviation sigma, I can scale x with sigma and then shift it by mu so that the center will be the new mean and it will be spread out according to sigma. This is kind of a trick from advanced statistics. Anyways, if I make x like this, where I take the original sequence, multiply it by sigma, and then add mu, and then I make my y the d norm of x with mean mu and sigma sig, the plot will be like this, and now you can see it's centered at 20, and the standard deviation should be 3. And that's how you would draw a normal distribution with any mean or standard deviation. Finally, let's look at fitting a curve to a histogram. First, I want to set a seed, so if you're following along, you'll get the same thing. I'm going to draw 100 random numbers from a normal distribution with mean 50 and standard deviation 10. And you can see I'm using the rnorm command. Now I'll draw a histogram of this. By default, the bars of the histogram represent counts of the items in the bins. That's what's meant by frequency on the y-axis. But if we set freq equals false, now you see the numbers on the y-axis changed, and it says it's a density histogram now. Now, the height of a bar comes from the area that the bin represents. If you look at the bar between 45 and 50, you see that the height is just about 0.04. If we look at how many elements are in that bin, that would be sum z greater than 45 and z less than 50. There are 20 of them, and I drew 100 numbers, so zero point 0.2 of the data is in this bin, 20 out of 100, 0 0.2. Now the width of the bin is 5, and the height is 0.04. 5 times 0.04 is 0.2. That's where the height, that's where these numbers on the y-axis come from. The reason we do this is we might want to check to see if our data looks like it fits a particular normal distribution. So if this is our histogram and we want to see how well it fits a normal curve with mean 50 and standard deviation 10, we can draw this density histogram like we have, then superimpose a curve on it. I'll get my x and y coordinates the same way I did before. I'll set mu equals 50 and sigma equals 10, and then plug them into this formula here. And now the only difference is that instead of using plot, I'll use this command lines. This will put a curve on a plot that's already been drawn. And you can see that the curve fits the histogram pretty well, as it should, because this histogram is a plot of a sample drawn from the distribution defined by this curve.